Last section, Unit 4, Section 4.8, curve fitting with exponential and logarithmic models. So we've actually done something very closely related to this, both in chapters 2 and 3, Units 2 and 3, and we'll talk more about that in a second. But for our warm-up, let's start off with this. We're asked to use x equals -2, -1, 0, 1, 2, 3, and 4 to make a table for the function f of x equals 1/2 times 3 to the x. And we're going to see if we can use this or do this without a calculator and leave all of our answers as fractions. So we're going to make an x column over here, and then we'll get a y column for our outputs. Starting off with -2. We're going to plug that in for the x, so we got 1/2 times 3 raised to the -2 power. Now a quick reminder on negative exponents, that's 1/2 times 3 to the -2. Well, if you think about 3 as 3 over 1, negative exponents mean you take the reciprocal of that number, so in this case 1 over 3, and raise it to the positive version. So 3 to the -2 is the same as 1/3 squared. So we're going to have 1 over 2 times 1/3 squared is 1 over 9. So we have 1/2 times 1/9, which gives us a total of 1/18. Folks, I don't expect you to show that much work for every one of these, but we're going to try this for another one. We got -1. Plugging that in, we got 1/2 times 3 to the -1st. Well, if we do that, we have 1/2 times 1/3, which gives us 1 over 6. Plugging in 0, we got 1/2 times 3 to the 0. 3 to the 0 is 1, so it's just 1/2 times 1, which is just, well, 1/2. Then we have x equals 1. We'll do 1/2 times 3 to the 1st. That's just going to be 1/2 times 3. Simplest way to describe that is 3 over 2. Next up, plugging in 2, we got 1/2 times 3 squared. 3 squared is 9, raised or multiplied by half, we got 9 over 2, 9/2. Plugging in 3, we got 1/2 times 3 to the 3rd. 3 to the 3rd is 27, times a half is going to be 27 over 2. Yes, I know these are improper fractions, but for now, I'm perfectly okay with that. Last one, 4, we got 1/2 times 3 to the 4th. Well, 3 to the 4th is 81, so times half is 81 over 2. So just kind of refresh on some of our exponential properties here. Next up is our goals for the day. We're asked to determine whether a given set of values is an exponential function. And we're also going to be given a set of data, and we're going to find an exponential function to model it. So just a brief refresher. We talked about these first, second, third, fourth differences and such, and talking about tables and looking at the y values. In a linear function, we've done this in the past. The first differences are constant. In a quadratic, it's the second differences that are constant. In cubic, it's the third differences. In quartic, it's the fourth differences. But then we switch over to exponential. We're no longer looking at differences, like what you add or subtract to get from one y value to the next. We're going to look at the ratios. In other words, we're going to be using division to determine if it is an exponential function or not. So, looking at this first example, we're asked to determine whether f is an exponential function of x of the form f of x equals a times b to the x. If so, what's the constant ratio? So again, ratio, we are looking at a division problem. Instead of just like what we did with the first, second, third, and fourth differences, where we took one y value minus the previous y value, we're going to take one y value and divide it by the previous y value. So we got 24 over 16. Now my advice would be reduce these fractions as much as possible. 24 and 16 are both divisible by 8, so we'll do divide by 8, divide by 8. We end up with 3 over 2. Looking at the next ratio, we're going to say, well, 36 divided by 24. Both of those are divisible by 12. So that gives us, that looks like a plus, sorry, let me clean that up again. And that gives us 3 over 2. Well, that's a pretty consistent ratio. 54, we're going to divide that by, I switched colors, sorry. 54 over 36, both of those are divisible by 18. And we end up with 3 over 2 as our ratio again. And finally, 81 over 54. So again, taking one y value divided by the previous. Both of those are divisible by 20. Man, I'm getting messy on my writing here. Both of those are divisible by 27. 81 divided by 27 is 3. 54 divided by 27 is 2. So yes, they are exponential. So f of x is exponential. And then the ratio, we're going to say, with a constant ratio of that same ratio we just found over and over and over, 3 over 2. That means the value, the b value, it would be f of x equals a times some value 3 over 2 to the x. We don't really know what a is. We could go back and figure it out. Actually, it's not too hard to figure out. It's 24. But we are just looking for the ratio. Every one of these is getting multiplied by 3 over 2. Let's check out another one. And we're going to do the same thing. So we've got determine whether this is an exponential function. So we're going to take these, we're going to do 3 over 2, see if we can reduce that. We can't. Hey, that's coincidentally the same as the last one. Next one, we'll do 5 over 3. That's not reducible. Folks, at this point, we can kind of stop. I'm going to keep going, but 8 over 5, that's not reducible. 12 over 8, that one is reducible. You can divide both of those by 2 and you get, sorry, by 4, goodness gracious, and get 3 over 2. Having a hard time writing here. So 2 of them match up, the other 2 don't. So this, we're just going to say, is not exponential. Now, not exponential, honestly, for this is probably a good enough answer. But instead of just settling for that, what I'm going to encourage you to do is kind of start over. Look at your ratios. So like going from 2 to 3, that would be a plus 1. 3 to 5, that's kind of a mess right now, but that's plus 2. 5 to 8, that's plus 3. 8 to 12, that's plus 4. And so it's not linear, but if we look at the second differences, so instead of looking at the ratios, now we're looking at differences. We got plus 1, plus 1, plus 1. So it's not exponential, instead it's quadratic. So even if it's not one of the ones or if it's not the one we're looking for, we can still determine which one it is.